Okay, so these practice problems are going to be in direct relation to polynomial division, which is what we learned the other day. So for this one, the polynomial function b of x is right here with a known factor of x minus 4, rewrite as a product of linear factors. So I don't have enough room, so I'm just going to put this piece of scratch paper underneath it so that you can see everything I have to do. So if this is my factor, make sure that we can see that. If this is my factor, it's going to be on the outside of the division sign. And then underneath is going to be x cubed plus 0x squared minus 21x plus 20. Okay, so right now you might be asking, Mr., where did the 0x squared come from? And that's a great question. This is a placeholder for the x squared value, meaning that it doesn't affect the equation, but we have to put it in there because we don't have an x squared term. So it just goes from x cubed to x. We need to put something x squared in there so that we can complete the division, okay? So you're always going to look from the first term to the leading term. How do I get from x to x cubed? So for those of you that have been having a tough time with this, I'll do it over here. X cubed is essentially x times x times x. And because we're dividing, I can say divided by our leading term out here, which is x. And then when you're dividing these cancel because x divided by x is just 1. So you're left with x times x, which is x squared. So that's how, this is kind of like the basic math behind how I get from x to x cubed. All right, so then what you do is you take this term up top, multiply it by each of these, and write it underneath. So we have x cubed and negative 4x squared. But remember that after you write these, you want to go through and change the sign, minus plus. So those cancel, this is 4x squared. Bring down the negative 21x. And do it all over again, x to 4x squared. So once again, we would have 4 times x, because that's 4x squared, divided by just x. And when you cancel that out, you're just left with 4x. Okay, that's going to be adding because it's positive. And then we'll have 4x squared minus 16x. And then you switch each of those signs after you write them down. So this would be negative 5x. And then this 20 comes down, plus 20. Then we're going from x to negative 5x, which is an easy one because it's just missing the negative 5, so that goes up top here. So then we have negative 5x plus 20, but remember we have to go through and change the sign, so this actually becomes negative 20, and we're left with a remainder of 0. So x squared plus 4x minus 5 is the other factor. And then ultimately we're going to get to where we can factor this, but I'm not going to worry about that today. Okay. For number 2, they want to know, here's our polynomial, here's a factor. Remember that factors give us zeros, which are what we call x-intercepts, okay? So to rewrite this function as a product of 2 factors, long division was made, but an error was done. How can we tell an error was made by the remainder? Well, if your remainder is not 0, then it's not a factor. So they said that x plus 9 is a factor, which means our remainder is 0. Okay, so if x plus 9 is a factor, our remainder will be 0. In this case, it's not, so we made a mistake. So let's see what our mistake actually was. X plus 9 divided by x cubed plus 7x squared minus 26x minus 72. X to x cubed is x squared. Come back and it's x cubed and 9x squared, and you're subtracting both of those, and you could see that's where the error was made. Right here they did plus 9x squared, and it's supposed to be minus 9x squared. But what they want to know is how can we tell by looking at the remainder? So our remainder was 990. If it's a factor, there is no remainder. And that's why I've kind of pushed so hard on the thought process of zeros and x-intercepts, factors giving you zeros and zeros being from factors, because this should be 0 as a remainder. And if it's a 0, then it comes from a factor. So hopefully we're starting to see the dots get connected a little bit. Okay, moving on to number 3. So for the polynomial function, right here, we know that x plus 5 is a factor. Select all the other linear factors. So remember that factors give us x-intercepts, or what we call zeros. So what I'm going to do is instead of dividing this out, we're just going to put it in the calculator and see where the x-intercepts are. All right, so in your calculator, x to the fourth minus 2x cubed minus 21x squared plus 22x plus 40. Okay, and then we're going to go to the table and we're going to look for wherever x is 0. Or sorry, wherever y is 0. Okay. So we have one at -4. We have one at -1. You can see right there, -1 and 0. 2 and 0. And see if we see any more. And that's it. Okay. Okay, so what we know, if these are x-intercepts, they came from a factor. Okay. How many are we supposed to have total? 4, because it's a 4th degree. So if x plus 5 is our first factor, then we can use these x-intercepts to find our other 3 to get a total of 1, 2, 3, 4. So if your x-intercept's -4, as a factor it's +4, because they're opposite. -1, +1. +2, -2. Those are your 3 factors. X-intercepts come from factors. Factors give you x-intercepts, and you want to remember that they're the opposite. Okay? So for number 4, match the polynomial with its constant term. You're just going to multiply these last numbers. So -2 times -3 times 7. So in the calculator, -2 times -3 times 7 is 42. So A goes with 42. This one, 2 times -3 times 7. Using -42, so -42 is B. Okay. Then this one is 0.5 times -2 times -3 times 7. We get 21. That's going to be C. And so on. So for this one, 5 times -2 times -3 times 7 is 210. So that's going to be D, and you're only left with E going there. So when they say constant terms, you're just multiplying everything that doesn't have an X, including what's out front. All right, for this one, what are the solutions to this equation? Well, what you could do is set x minus 2 equal to 8 and x minus 4 equal to 8, and then just solve for x. So we got 10 and 12. Okay, pretty simple. I know I'm powering through this, but it's pretty simple stuff. And then the last one is number 6. Or sorry, we got 2 more. Starting with number 6, though. Here's a graph. Which statement is true about the end behavior? So we know that the end behaviors are opposite. And this is the x side, so this is the positive side of x. This is the negative side of x. As x gets larger and larger in either the positive or negative direction, f of x gets larger and larger in the positive direction. So this one's not true because the negative side is going down, the top is going up, so they're opposite. As x gets larger and larger in positive direction, so as we go to the right, f of x gets larger and larger in the positive direction, so that's true. As x gets larger and larger in the negative direction, f of x gets larger and larger in the negative direction, meaning that as we go to the right, it goes up, as we go to the left, it goes down. B is going to be the correct end behavior for that one. As x gets larger and larger to the positive direction, y gets larger and larger. So as x goes to the right, y goes up. As x gets larger and larger in the negative direction, or as x goes to the left, the graph gets larger in the negative direction, or the graph goes down. All right, and then the last one, rewrite the product of linear factors and then draw a rough sketch. So for this one, I'm just going to divide it real quick. All right, so x plus 4. Let me make sure you guys can see that on the phone. Yeah, okay. Divided by x cubed plus 3x squared minus 6x minus 8. So we got x squared gives us x cubed, and 4x squared, subtract. Negative x squared minus 6x. That's minus x. So plus x squared plus 4x. 2x and -8. That's just a -2. And I'm going to leave that there. So I have x plus 4 times x squared minus x minus 2, and I know that I'm supposed to have 3 x-intercepts, so I have to factor this. So two numbers that multiply to -2 that combine to a -1 are a -2 and a +1. So I would have x plus 4, x minus 2, x plus 1. And those give me x-intercepts at -4, +2, and -1. Okay? So then what my graph would look like, because the whole thing is positive, is at -4, I would have an x-intercept. At +2, I would have an x-intercept. And at -1, I would have an x-intercept. Because it's 3, they are opposite endpoints, and they're positive. And then it goes through each point one time.